All right, so today we're just looking at sine and cosine. And you need to know and have memorized here that the derivative of sine is cosine and the derivative of cosine is negative sine. Okay? So derivative of sine is cosine, derivative of cosine is negative sine. Those must be memorized. You're going to use them over and over and over and over and over again throughout this class. So make sure that you lock those away. We're probably getting to the point that I need to give you like a formula quiz on some stuff. We might try to do that before we take our next test, but I don't have that together. Because that is one thing that I think I need to do along the way more, because I was noticing last year that I was having several students miss things they shouldn't because they did not have things memorized. So we may do some formula quizzes on that. And formula quizzes are, as long as you don't mind studying a little for a formula quiz, are always good for your grade because, you know, I could get Hunter to ace a formula quiz. He wouldn't know what in the world he was doing, but he could memorize it if I made him spend enough time on it, right? So, now hopefully you guys also know what you're doing. But if you don't have it memorized, it doesn't matter if you know what you're doing, because if you don't know the derivative of cosine, you're, you know, just out of luck there. The ones we're going to be doing today, very straightforward. Okay? So if I'm taking the derivative of f of x equals 2 cosine x, f prime of x is going to equal, whenever we have a coefficient right here, the coefficient is just going to be 2 times whatever the derivative is. We just leave the coefficient there. So it's 2 times the derivative of cosine, and my derivative of cosine is negative sine x. And that is just going to give me negative 2 sine x. That's it. And you can skip this middle step here. Go straight to negative 2 sine x, if you please. Now the second one looks like a fraction. But could we rewrite it so that it's not like a fraction where we've got sine divided by something? We could write it as 1/2 sine x, so that that 1/2 is just a coefficient, right? Even though it's a fraction, it's still just a coefficient. So if we take the derivative of this, 1/2 is just a coefficient. It just sticks around. The derivative of sine is cosine. So we just get 1/2 cosine x. All right. For number 3, we need to take the derivative of this. F prime of x. We've got a mixed function here, right? It's got a linear component, but it also has that trig component. But they're separated by a minus sign. Whenever we have terms that are separated by plus or minus signs, we just take the derivative of each one of them separately. So derivative of 2x is just 2. The derivative of sine is cosine, so we'll have 2 minus cosine x. We will do some trig that gets more complicated than this, but not today. This is what you'll see today. I think. Let me look at the next example to be sure. Yeah, because we're going into exponentials here. So today, trig, very straightforward. You just need to know derivative of sine is cosine, derivative of cosine is negative sine. All right, the derivative of a to the x power. A here is a real number. Typically, it's going to be an integer, but I don't guess it has. Well, a also is going to need to be greater than 0. Because can we take the natural log of 0 or a negative number? We cannot. So a needs to be greater than 0, and it needs to be a real number here. So, the derivative of an exponential is itself times the natural log of the base. Okay? So, if I'm taking the derivative of y equals 3 to the x, then I'm going to use this notation dy over dx. Or if you use y prime, that's also okay. It's just going to be 3 to the x power times the natural log of 3. If we take the derivative of that second one, 5 is our coefficient. So when we take the derivative of something, if we have a coefficient, it just stays right there. Derivative of 1.2 to the x is going to be 1.2 to the x power times the natural log of the base. So natural log of 1.2. And they might write it like this, 5 natural log of 1.2 times 1.2 to the x. They might pull those like numeric terms out front that don't have variable. Okay, this is a formula you must have memorized. Okay, AP exam does not give you a formula sheet at all. So all formulas basically must be memorized. What they will do occasionally, if you have a problem that needs the volume of a cone or something like that, which we won't see for a while, they will sometimes give you the volume of the cone in the question. They'll give you that formula. But as far as just your derivatives, integrals, the stuff that we're going to do, no formula sheet for any of those. It all has to be memorized. So this one is another one. Must be memorized. Although I will put a little asterisk here. These don't show up very often. They do show up, and I have seen them on the AP exam. But they don't show up that often. What we do see a lot more is the derivative of e to the x. We see this a lot. And sometimes students see it and they hate it, but e to the x should be our favorite problem to get. E to the x is a really odd equation. There are not many. Is there anything else? I don't think there's anything else. I could be wrong about that. I need to look this up. I'm not aware of anything else. There might be something. I don't want to say this too strongly. But it is its own derivative. E to the x is its own derivative. So, if you need to know the slope of the tangent at any point, it is equal to e to the x. It is equal to itself, right? Whatever f of x is, f prime is equal to it. Okay, so this makes this super easy. Now, this is the same rule. If we use that same rule, if we're doing the derivative of e to the x, and we use the same rule that we used on the last problems where we were doing the a to the x, the derivative of a to the x equals a to the x times natural log of a. It's actually not a different rule, because the derivative of e to the x would be e to the x times the natural log of e. But what is the natural log of e? It is 1. So it's e to the x times 1, which is e to the x. So it is actually the same rule. It's just natural log of e equals 1. So we will just have e to the x. Now, this one's going to show up a lot. We're going to use this often. Okay? But we should be happy whenever we see it, because it's super easy. F prime of x for number 6 is going to be 3 e to the x minus 4. Right? So if you have a derivative of an e, it's just itself. Now, right now, we should only see e to the x power. We will not see e to the negative x. We will not see e to the negative 4x, e to the 2x. We should not see that. So if you see a problem like number 7, this has some issues. First of all, the e to the x is in the denominator, and it's not just a straight e to the x. It's e to the negative x. How can we remedy this situation so that we can deal with it? Move it up to the numerator. We'll get 6e to the positive x. And so when we take the derivative here, it is 6e to the x. I love each of the x's. Okay? Derivatives of logs. If you take the derivative of log base b of x, it is going to be 1 over x times the natural log of b. So for, this is another one. It's got to be memorized. We'll do a formula quiz before test 2 to make sure that we've got all these. Y equals log base 5 of x would be our derivative, y prime or dy dx, however you want to label this, would be 1 over x times natural log of the base, which is 5. And for the second one, for g prime of x, the 6 is a coefficient. It's just going to hang out front. Then we would have 1 over x times natural log of 4. And probably you would see this written back together. That's like 6 over 1. We're multiplying here, so it'd be 6 over x natural log of 4. Okay, here. All right. Now, new rule for natural logs. Really, it's the same rule. Okay? Because if we do the same rule, if we're doing natural log of x, derivative of natural log, oops, let me write that as a x. What is the base for a natural log? It's the same as doing log base e, but we just call it a natural log. So your base is e here. So your rule, if we use the same rule for this, we would have 1 over x times natural log of e, because e is your base for a natural log. But on the last one we talked about this, what does the natural log of e equal? It is 1, so it just gives us 1 over x. So it's not really a different rule, it's just that natural log of e equals 1, so it goes away on this. Again, same thing with these. You're much more likely to see a natural log in problems than you are like a log base 5 or a log base 10 or a log base 2. Most likely you'll see natural logs. This is going to be more common than the problems before. So if we had 4 natural log of x, the derivative would just be 4 over x. I mean, I could have written it 4 times 1 over x, but that's just 4 over x. If we had a problem like number 11, I really need, before I do this problem, before I take the derivative, I need to deal with this 1 over x squared, and I need to write it as x to the negative 2. Then I can take the derivative. So dy dx, or y prime, whichever one you want to call it, would be 6 over x, and then we'd have plus 2x to the negative 3. Now, the book, free response, perfectly fine to leave it like this. The book's probably going to do some crazy stuff with the way they give this answer. There is a decent chance that they will do 6 over x plus 2 over x to the third. It is also possible they might get common denominators there and put those together. So if they did that, you would need to multiply this by x squared right here to get that x to the third. So you would have 6x squared plus 2 over x to the third. Again, perfectly fine to stop here, but I do want you to look in the back of the book and try to get your answer to match whatever they have. That kind of helps you practice for some multiple choice sort of situations. Okay, all right. So let's do a few tangent line problems. And so if we are going to write the equation of the line, tangent to the graph of f of x equals 4x minus natural log of x at x equals 1. Tangent line problems, we got to have 3 things. Wesley, what's one of those 3 things we got to have? Point, right? And how do we find the point? Good. So we'll do f of 1, 4 times 1 equals minus natural log of 1. Oh, what is natural log of 1? These are ones that we're going to need to have. I might put it on the formula sheet too, even though it's not really a formula. But natural log of 1, think about this, equals, I don't know what it is, I'm going to put an x right here. Right? What's the base on a natural log? E. All right, so if I want to solve this, or if I want to rewrite this so it's not a natural log anymore, I would do e to the power on both sides. So 1 would equal e to the x power. What's the only thing x could equal that would give me 1 here? 0, right? E to any power is 0. So natural log of 1 equals 0. That is something that we need to make sure that we know. In a similar manner, it's not on, you don't need it on this problem, but natural log of e equals 1. So I might put those on formula sheets as well, just because they'll show up. So this is really just 4 minus 0, which of course gives us 4. So we got the point 1, 4. All right, so we got our point. Hallie, what else do we need to write the equation of a tangent line? Slope. And how do we find slope? What gives us that slope? It's not f. F gives us where the point is at. F prime gives us the slope, right? So we need f prime of x. And Hallie, whenever we do the derivative of 4x minus natural log of x, what will we get? Perfect. 4 minus 1 over x. We particularly need the slope at 1. So we're going to do f prime of 1, which is 4 minus 1 over 1, which will just give us 3. So that's our slope. And so now that we've got our point and our slope, what's the last thing we need to do, Grace? Write the equation. What's it going to be for this one? Perfect. Okay. Lots of times when they give you natural logs, they'll give you points that actually end up giving you whole number answers. But if I'm remembering correctly, 13's not like that. They also do this to you sometimes on the calculator in active problems. And this bothers me because I like having whole numbers. I don't like crazy answers. But if I'm remembering this problem correctly, I think we're going to get some crazy answers on 13. So the line y equals mx plus b is tangent to the graph of g of x equals 3e to the x plus 2 at x equals 2. What are the values of m and b? So the way they have asked this question, they're still asking for the equation of the tangent line, but they are making you give the answer in y equals mx plus b form. So where we usually leave it like this, it's asking us to give it in y equals mx plus b form where we can tell what the m is and the b is. So it'd be really easy on number 12 if it was worded this way. We just distribute that 3. We get a slope of 3. Whenever we distribute 3, I think we'll get 1 for our y-intercept. We just distribute y equals mx plus b, give m and b. It's not as easy on this one, though. And they do this to you sometimes. So I talk about them a lot, the AP people, like they're some like mysterious, evil mathematical geniuses that give us all these problems, and maybe they are. I also talk about that test a lot, but it's a good test. Like if you pass that test, you know how to do calculus well. So even though I'm talking about it a lot, like it's also just like good mastery of, they're good questions, good mastery of calculus. If you can make a 5 on the AP calculus exam, you know how to do calculus well. And if you make a 3, you got a pretty decent understanding of calculus. So we need 3 things. Zach, what's one of them? Point. And what do we do to find the point? All right. So that's going to be g of 2 equals 3e squared plus 2. This is calculator inactive. Can you do anything with that? No. So your point, this makes me cringe a little bit, but your point is 2 3e squared plus 2. All right. We need to take the derivative now to find the slope. Connor, when we take the derivative of this, what will we get? Just 3e to the x. That 2, its derivative is 0. It goes away. All right. So derivative, pretty straightforward. We need to plug in 2. And so that's going to be 3e squared. That's our slope. And so just like every other problem, we are plugging into the y equals m times x minus x1 plus y1 here. We are going to need to do this to find our b. So we could go ahead right now and say m equals 3e squared. Right, so we could do, that is definitely our m. But to find our b, we need the y-intercept. So we're either going to have to do this, or you could do like the y equals mx plus b formula and do it like we did when we were in Math 1. That would work also. Since we're kind of conditioning ourselves to do it this way, I usually do it this way. But we do have to do this part to be able to find b. So we are going to do y equals 3e squared x minus, you got to be careful right here. You are subtracting, I'm sorry, not right here. This is not where you got to be careful. You got that minus 2, and then you got plus 3e squared plus 2. You don't have to be actually as careful as I was thinking, because since that's our y coordinate, these parentheses are not totally necessary because you just have positive here. But if you have a negative, or if you're like, if that was your x coordinate, you gotta be real careful right there. So we need to know the b, which means this needs to be y equals mx plus b form. So we're going to distribute our 3e squared. So y equals 3e squared times x minus 6e squared plus 3e squared plus 2. And then if we combine the like terms that we have here, we're going to get minus 3e squared plus 2. So it's ugly, but we already said that 3e squared, that's our slope, right? Then you got your x right here, and then it's going to be plus the b. All of this stuff right here is your b. So b would equal negative 3e squared plus 2. Okay, questions? Okay, so your assignment for tonight is going to be to do these problems from your book, and I think those should be correct today. And then our book does not have a lot of problems with things that are different bases, or find a, I guess it didn't have a natural log there either. So I added 5 problems there. So those last couple slides have those 5 problems that you're going to do for me, plus the ones in the book. Yay, we actually have some time to work today.